Good morning. I'm going to do another video dealing with circular motion. So this ties into universal gravitation. So let's go ahead and jump into it. When we're talking about circular motion, we have something that's like this. Let's say that you have a person that's standing in the center or standing here, and they have a string, and tied on this string is some type of a toy. Let's say that it's an airplane. And if they're swinging it around and around while they're in the center, let's say that they have this airplane going, creating this circular pattern. So this is going to be our circular motion that we're referring to. And so notice he would be in the center, the toy, the object, whatever it is that's moving is moving in this circular path. And so if we take a look at it like this, we could say that we're looking from the top down. So this would be the person here swinging the toy. This is going to be our airplane, and then this is our string or rope that's attached to that object. So notice the arrows, they're pointing. We have this circular motion, this counterclockwise circular motion that is occurring. Now, when we're talking about circular motion and what that is, we have to remember this idea of inertia. Newton's first law dealt with inertia. And inertia was mass. Those two words are interchangeable, inertia and mass. But if we talk about what inertia is, we could say, or what the idea of inertia is, that we could say that the object wants to stay doing what it is doing. It wants to stay doing that. So if it's moving, it wants to continue moving. If it's at rest, it wants to stay at rest. Now, the part about moving is that an object will continue off in a straight line unless you have an unbalanced force. So an object wants to stay doing what it's doing unless there's an unbalanced force. So if the object is moving, then it's going to continue moving in a straight line. It'll continue moving in a straight line until you have that unbalanced force. So this plane, this toy, wants to move in a straight line. It wants to move off in that straight line. But it doesn't follow that straight line motion. Instead, what it does is it follows this path here, this circular path here. And then you could say anywhere. Let's say that I put the plane right here at this point, right? Let's say that the plane is here. It wants to move off in a straight line, but it can't. Instead, it follows this circular motion. And so that would go for anywhere. We could say that down here. Here's our plane. It wants to move off in a straight line, but it doesn't. It can't. Again, it follows this circular motion here. So we know that it doesn't go off in a straight line. We can see and we can tell, and you can do this yourself. You can see that it goes in a circular path here. So why is it that it goes in a circular path? Well, remember, this toy is tied to a string. It's tied to this, right? They're holding on to this. So there's a tension force in the string, in this rope. So this force is directed towards the center. It's that tension force in that string. And it doesn't matter if we're talking about up here at the top, if we're down here at the bottom. That force is always causing this toy, this object, to move in a circular path. It wants to move forward, but you have a force that's perpendicular to it, so you get this circular motion. Here, you have a force. The toy wants to move forward. Your force is directed towards the center. And so instead of allowing it to move forward, you have this perpendicular force that causes it to curve. So anywhere, I mean, you could put one here too, if you put that plane here. The planes are getting worse, but yeah, it wants to move forward, but anywhere along that path, you have this force, and it's towards the center of the circle. It's a center-seeking force. It's called the centripetal force. Your centripetal force means center-seeking force. So anywhere along this path, this circular path here, you're going to have the force directed towards the center of that circle. Included in that We don't necessarily talk about it too much, but remember, a force causes some type of an acceleration. And so acceleration would also be towards the center of that circle, because a force and acceleration are always in the same direction. So we have centripetal acceleration, centripetal force, they're center seeking. So the force is always towards the center, acceleration would always be towards the center. Okay? Yeah. The object wants to stay what it's doing. It wants to move in a straight line. It's moving in a straight line. It wants to move that way, but it can't because there's an unbalanced force. What's that unbalanced force? It's this centripetal force, center seeking force. Now, what would happen if you had this plane and you were spinning it around and it was going around and around in a circle, like it was here, but let's say that the string suddenly breaks? What type of motion would the plane have then? Well, if there's no string here, there's no tension force, so there's no centripetal force. You can't have a force if the string is broken. So you've now gotten rid of the force. So once you get rid of the force, what's the plane going to do? What does it want to do? What is it going to do? It's going to move off in a straight line, right? Because it wants to continue what it's doing. So it's going to move, and it's moving in a straight line. It will move in a straight line. This is called your tangential velocity. It's a line that could be drawn tangent to the circular that was being created here, your tangential velocity. Just know that it would move off in a straight line. It would not curve. It would not curve at all. It wouldn't curve at a small amount. It wouldn't curve a large amount. It would move off in a straight line only. So that's pretty much about it. If you have any more questions, definitely ask your teacher for more help. Thank you very much.